All right, we're almost done with this. Let me get a share screen going. So the last thing I want to do is set up these scenes, these various levels that we're going to transition among as we play our game. In any proper game, there's an opening scene. In the opening scene, you choose characters, you pick level difficulties. Sometimes the opening scene can show instructions for how to play, that sort of thing. From that scene, we transition into one of the play scenes. We play and then either win and lose. And when we win or lose, we transition to a scene that somehow reflects that fact, and then cycle back to the opening scene so that you can play again. So we want to have a start scene, one or more play scenes, a win scene, and a lose scene. And transitions among these scenes are done with the scene manager .load scene command. In some of the older tutorials, you'll see reference to an application load level command. It's now deprecated. Using the scene manager class requires using Unity Engine scene management in any of your scripts that use this scene manager class. So in the start scene, we might have some basic terrain. It can be empty if you want, but it's more interesting if it has something in it. Lights, camera, so forth. And we can include a 3D text object, one of these that has a text mesh component on it. And we can put something like press any key in that text object. So here's the text object. It has a text mesh on it. It says press any key. And I have a little simple script here, start game, that does nothing more than load the play game scene when input any key is pressed. This will trigger when any key on the keyboard is pressed. For this to work, the play game scene must be included in the build settings. Build settings are accessible from the file build settings pull down, where we have all of the different scenes that I've included here in my game. To load a scene to the build settings, you load that particular scene and then press add current, and it will be added to the build settings. Later, when we deploy a game, whatever you want to be your opening scene should be the first one. So the build will start with scene 0, the first one. So that sort of press any key is fine, but if we have a choice that we want to make, we could use a button feature of our UI. We can replace that press any key with a select scene and include a canvas with a panel with children containing buttons for each of your play scenes. I'm going to do a day scene and a night scene. Both the panel and the buttons can anchor to all 4 anchors in the center. That way it'll stay centered in the center of the screen and it won't expand or contract. We can label and color our buttons appropriately and add on-click events that reference the select level script that I've attached to some object in the scene. So here in my now start scene, I have this select level text. It has the select level script on it that has the appropriate functions. Public load level, I'll show you that in a second. And we have our canvas with our buttons, level 1, level 2 buttons. So we have all these buttons. So the select level script contains the functions that are on-click events in the respective buttons used. Uh, I've made it simple here. When I want to load level 1, the day game, I call load level 1, and when I want to load the night game, I call load level 2. So each of these buttons has an on-click event that's appropriate for the level that they want to load. Um, the other thing is that we need to do something with the win and kill functions. Back in our player status script, we had apply damage and add points, and when the health dropped to 0 or below, we called kill, and when our points went above 100, we called win. And now all we need to do is add to those functions the scene manager load scene dead for the kill function and the scene manager load scene win for the win scene. And remember, we have to add the using Unity Engine scene management in the player status function in order for this to work. The win scene is similar to start. It might have a terrain, a camera, a light, a 3D text object that tells your user, yeah, you won, and that has a restart game script that is just a little timeout before it returns to the start scene. So our win scene is going to hang out for a little while and then return to the menu, to the opening scene, to the start scene. And we can do this two ways. One is with a coroutine restart that uses the wait 4 seconds before it loads the start scene. This is one of these coroutines with an IEnumerator. Uh, we'll talk much more about these in detail, but if you want to use the wait 4 seconds, it has to be a coroutine. The other way you can do it is with the invoke function. The invoke function takes a string name for the function to call, your restarter, and here's the function restarter, which just loads the scene start. And the invoke function has the second argument, which is how long we want to wait before we invoke the restarter function. In many ways, this is a little simpler than using the coroutine setup. Works the same way though. The dead scene is similar to start and win. We've got some stuff there to look at, a camera, a 3D text object telling the player they're dead. I got kind of fancy with some of this stuff. I have a child object with a countdown script that continually instantiates 3-dimensional text objects. These are prefabs whose text I set in the script, and they have rigid bodies, so they fall as they count down. Let me show you this scene. This is the dead scene. So these text objects are continually produced, and they have rigid bodies, so they fall and hit the ground. And I've got bombs going off in the background too. And when it's done, it goes back to the menu page, which is what I wanted it to do. For this, we use the coroutine to start count. Count is goes through a certain number of loops, the wait time, counting down from whatever the wait time is by 1, instantiating this number prefab that I have, fetching its text mesh component, and assigning to the text of that text mesh the counter converted to a string. It waits a second in between each of these, and when this for loop is done, it waits another 2 seconds, and then it loads the new scene. Just for fun, there's also an explosion, a countdown explosion that works basically the same way. It instantiates a detonator. I've used the mushroom cloud at regular times at randomly chosen positions. So the coroutine count is a while true loop. This is going to keep doing this forever. Of course, the scene eventually transitions, and so that's shut off. Here, offset is this random number in the range, minus range to plus range. So our bombs are going to be scattered around the landscape. I instantiate the detonator at a position plus this random offset, and I wait a few seconds, and I don't bother to clean it up since the scene doesn't last very long. Now, the last thing we need to do is publish our game, compile it so that we have something that we can distribute. And as I mentioned above, uh, uh, all of these scenes have to be included in the build settings. So the build settings now over here for my game that I'm going to compile include the start as the first one, and then the rest, the order doesn't matter. I've got play game day, play game night, dead, and win. The one key here is that the start scene has to be the first one in the list, number 0. Now, these numbers also can be used to load a scene. So where I loaded all the scenes with strings by their name, you can also load scenes by their index, 0, 1, 2, 3, and 4. So sometimes that's easier, although you do have to maintain an order in order to make sure things are working correctly. The build settings include the platform for which you wish to build. There are many, many platforms for Unity. I have the build for the PC, and I have the build for WebGL. And something to note here are the quality settings. And this we see in the player settings here. The player settings for our different players, we have the quality settings. We have two different columns here. One is for the PC and the other is for the web. And these go from fastest to fantastic. I believe for the PC, the little green one is the default. For the WebGL, this little green one, good, is the default. And it's worth having a look at what the different settings are that affect the speed and quality of our game. Fastest is going to be that which is capable of running on the least competent hardware, whereas fantastic might require a pretty good graphics card in order to do it. But that's worth having a look at. The other settings are in the player. The player, we can set the resolution, and for the presentation, the width and height of the canvas that we're going to use. There are some other settings here that we don't really need to worry about. The defaults are generally all we need to change. Resolution and presentation is how big your window is going to be in your web player. So that is somewhat important to do. So have a look at the different settings and see the different quality options that you can choose. These include things like how many pixel lights there can be, the point lights and spotlights, what kind of shadows are used, and many other things that affect both the GPU and the CPU necessary to render your game. For turned-in games, I will accept WebGL as a non-development build, as it's really a lot smaller than the development build. Or if you happen to have the Mac OS build, I will accept one of those. I will not accept Windows builds as I don't have a Windows machine and I'm unable to play them. But I can play either Mac OS or WebGL. I have found that any errors, null references, and so forth prevent WebGL from building. It'll give you errors and say, sorry, can't do it. The Mac OS build seems a little more forgiving, especially if the development and debugging are checked. If the first time you downloaded your game, you didn't include the WebGL compiler, you may have to go back to the Unity store and add that package. It's a big chunk of change. It's a gigabyte or more. When submitting the WebGL, if that's what you choose, here's what the WebGL looks like for one of these. This is my uh, uh, this is my build for uh, for this sample game. There are two folders. There's a build folder and a template data folder, and an HTML that is the web page that one opens. I need all of these. So the thing to do is to zip this folder up into a single something and hand that in. That would be the thing that you'd hand in, the zipped up folder. These web builds are pretty efficient, so that's only 9 MB. It's not a big chunk of change. Uh, uh, Whereas the game folder itself is 32 MB. So uh, it is pretty efficient. So that's all I have to show you here. We now have a fully functional game with opening scenes. Well, let me play it just so you can see it. Uh, so I go into the daytime game. I'm going to win it quickly. I have the sound turned off so that I'm not making too much noise here. Uh, and 4 of these gems should win the game for me. If I can get the game. So I won. It's now cycling back to the menu. Here's the nighttime scene. Uh, this one I'll quickly lose. Uh, and I am dead. And the uh, game is over. Um, and it does cycle back. And this was said a little funny. Okay, so I'll stop sharing at that point, and stop the recording and see you all in class. Bye.